Assalamualaikum, how are you guys doing? I hope you guys doing great, and in this video we're gonna learn how we can use 3D model inside our website using Three.js. So without any further ado, let's get started. So here I have the demonstration that what we're gonna learn in this video. So this is the 3D model which we're gonna load in this video, and as you can see we can interact with this model. We can move it around and we can zoom in and zoom out, and moreover we can change the lighting directly from here. We can change the lighting as you wish. As you can see, we can change the lighting, and I'm using 3 lights and everything we're gonna see in this video. And also we can see the FPS or frame per second at the top left corner. And also I have added some HTML elements, so we're gonna see all those things in this video. And also we're gonna do this using Node.js, so we're gonna use the Three.js as a module of Node.js. Okay, so to get started with this project, you just need an empty directory. I just call it 3D model load. You can call it anything you want, but make sure that you don't have any white space between your directory name, because we're gonna use Node.js, and while creating Node.js package, white space can create some trouble. So make sure you don't have any white space in your directory name. And inside of that, your root directory, you need app.js and another folder public. And inside of this public directory, we need the model. I have this. Okay, so I have this model inside of our model folder, and beside that you need client.js, and this will be the JavaScript file which we'll use to do all those Three.js stuff. Okay, and then we have index.html and then style.css. So this is all for our folder structure. And then what you have to do, just go back to root directory, and in here you have to open the VS Code or any other code editor you prefer. Okay, now you have to open a new terminal. If you are in VS Code, just go to terminal and new terminal. And if you are not using VS Code, you can use CMG or inbuilt terminal in your preferred code editor. Just make sure that your terminal is open in your root directory. In my case, this is 3D model load. And then what you have to do in your root folder, you just have to say npm init-y. Well, before that, for this code to this command to run, you need node install. To install the Node.js, you have to say just go to Google and search for Node.js download, and then open this website called nodejs.org. And once you're in this website, you can download your Node.js version according to your operating system. And once you download that and install it on your computer, then you will be allowed to run this command. Let's just hit enter after installing Node.js, and we have a package.json file. Well, so now we need few more things, like we need Express.js to make our server. So as we're working with Node.js, we need a server to serve our static files, right? So if we are using Three.js and if we are importing some external models, then we need a server to serve that static model. So for that server, we're gonna make our own simple server, or you can use any other server which is available freely, but we're gonna use our own server. So for that, we're gonna need Express.js. So for that, let's go to our terminal and let's say npm install express and hit enter. So it will install the latest version of Express.js. Okay, so Express is installed. Now let's install Three.js. So npm install 3 and hit enter, and let's just wait for it to install. Okay, so Three.js is also installed, and now inside of this package.json, let's just add a start command, and this start command is going to be node app.js. It's basically saying that whenever we are going to run this start command, I want to run this command. Okay, so this app.js is going to be our server basically. Okay, so now let's go to our app.js and let's start building our server. So for that, let's say const express equal require express, and then we need an instance of this express. So let's say const app equal express. Sorry, what did I type? Express. Okay, and then we need another thing called path. Const path equal required path. So now we have to define the static folder, the static directory, that whose directory we want to serve. So let's say app.use express.static __ dir name, and then plus public. So we want to serve the public folder or the public directory, as we want to use the Three.js as a module. So what we have to do, I have to say app.use /build and express.static path.join directory name, and now we have to give the relative path of our Three.js module. So the Three.js is inside of this node module, and then inside this tree and inside of this build directory, you can see inside of this build directory you can see this 3.module.js. so we're going to use this. So we have to give the relative path of this file, so which is node modules /3/build. Well, I'm not gonna explain really much about this server because I want to focus on Three.js part. So you just can copy paste this code inside your app.js. So I'm just gonna go quick with this. So app.use JSM and express.static path.join _ dir name node modules /3/examples/jsm. So this, what is this line is doing, inside of this node module and inside of this the example folder, if I go to the examples, and inside of this JSM folder you can see some utility files which we will need. Like we'll need these controls, we need orbit control, so we'll get the orbit control from this piece of code. And then we're gonna need a gltf loader, so this is inside of loaders, and here you can find a gltf loader. There we go. So there it is, this is the gltf loader. So also we're gonna get this gltf loader from this JSM directory. So now let's say app.listen, and the port number is gonna be, let's say 4000, and a callback function. And inside of this, let's say console.log, and let's say visit http clone //127.0.0.1 colon, the port number is 4000 or 3000. Yeah, so with this our server is ready to run. Now before we work with our server, we have to work with our index.html file. So let's go to our index.html and let's create a boilerplate. If you are in VS Code, just type !mark and hit enter. And then you have to add our client.js in here. So let's say script, and you have to give the type of this app.js as module, otherwise it's not gonna work. Make sure the type is module, and src is gonna be client.js. okay, and now let's add the CSS file. So link relationship is a style sheet, and hyperreference is gonna be .style.css, and inside of this body let's create a canvas element. So canvas, and let's class is wave GL. So we're gonna render our 3D model inside of this canvas element. Okay, so with this, if I run our server, what you have to do to run our server, all you have to do is inside of this terminal, let's type npm start and let's hit enter. And now control and click on this, and there you go, our nginx.html file is showing up. Okay, so now let's go to our client.js, and now we're gonna start to working with our Three.js. First of all, we have to import the Three.js. Okay, so for that, let's say import asterisk as 3 from build /3.module.js. So basically it's saying that import all as 3 from 3.module.js. okay, and let's just console log it to see if we import it correctly or not, and hit enter and refresh it, and let's go to the console, and yeah, we are getting the module, so that's mean we have imported it correctly. So whenever you are working with Three.js, and if you want to create a 3D scene, you need few things which is essential. That means you need always you need those few things, and one of these is scene. So let's create a scene. So the scene is basically the whole container for your 3D scene. Okay, so anything you can see inside of your 3D animation or whatever you're creating in 3D is basically inside of this scene. So we need that scene, and then we need a camera. So we need a camera is because we can't see anything without camera. Whatever you wanna see, you have to see through the camera. So we need a camera, and then we need a renderer. So you can't see anything until or unless you render the scene. So for that, we are gonna need the renderer. Okay, so then let's create our main function. Let's name it init, and this is gonna be arrow function, and beside that, let's just call it as well window.onload init. Okay, so we called our init function, and inside of this init function, you have to initialize the scene. So do that. Let's say scene equal new 3.scene. Make sure this is capital. Okay, and now let's console log it to see if our scene is perfectly working. So let's go to there and refresh it. So there we can see our scene is console logging, so that's mean our scene is perfectly fine. Let's comment out this console logs, and then we have to set up our camera. To set up a camera, we need to keep in mind few things. First of all, to set up a camera, we need a field of view, means FOV. We need an aspect ratio of our screen, and then a near value and a far value. So let's say const FOV is equal 40, and const aspect is equal window dot inner width divided by window dot inner height, and then we need a near value, let's say 0.1, and a far value, let's say 1000. So what is this doing is this FOV is field of view, means how widely you can see. If you increase it too much, if you increase it something like 120, so it's gonna act like a wide angle lens. Okay, but we don't need that much of wide angle lens. We need just this 40 is gonna be fine for this example. And the aspect ratio of your browser window, and to get the correct aspect ratio, all we have to do is you have to take the window width by saying window dot inner width, and then dividing that window width by window height. and then a near value. So near value is representing is, so this near value is basically saying that if the distance between your model and your camera is less than this unit, then your model is not going to be visible. And similarly, if the distance between your camera and the model is greater than this value, also your model is not going to visible. And if you want to learn more about these things, you can check out my previous video about Three.js. And now what you have to do, let's say camera is equal to new 3 dot perspective camera. So we're gonna use perspective camera. You can use other cameras as well, but perspective camera is going to be perfect for this example. Again, if you want to know more about these things, you can check out my previous video on Three.js. I'll give the link in the description. And inside this perspective camera, you have to pass the FOV, field of view, and the aspect ratio of your window, a near value and a far value. Okay, again let's console log it to see if our camera is working well. Let's go and refresh. Yeah, our perspective camera is working fine. Okay, then we have to set a position for our camera. So let's say camera dot position dot set, and in here you have to pass x, y, and z value. So for x and y, let's say 0, and for z value, let's say 25 or 25. Okay, so now we have to add the camera in our scene. So for that, let's say scene dot add camera. We have to create our renderer. So let's say a renderer equal new 3 dot WebGL renderer. So we're gonna use WebGL renderer, and inside this WebGL renderer, what you have to do, so then you have to say that where you want to render your scene. So we want to render our scene inside of this canvas. You remember, we want to render our scene inside of this canvas. So let's copy this, copy the class name, and let's go to top, and let's say let model container equal document.query selector, and the class name of our canvas. And now inside of this renderer, what you have to do, set the canvas to model container. Okay, and also you can set anti-alias to true. So what this anti-alias is doing, so if you have some thin object in your scene, it's sometimes looks jagged. So to remove that jaggedness from that thin objects, you just can use anti-alias to true. So then we have to set a size for our renderer. So let's say renderer dot set size, and the size is gonna be window dot inner width and window dot inner height. Okay, so at this point we should see a black screen. So if I go to the browser, and yeah, we can see the black screen, but if you notice that it has some space around it. So to remove this, we just have to go to our style.css, and here you have to type the universal selector, and margin is 0, padding 0, and box sizing to border box. Okay, so now if I refresh it again, problem is solved, but we have some vertically scroll bars. We're gonna remove this as well, don't worry. So then what you have to do, renderer.set pixel ratio. So we're gonna set the pixel ratio of our renderer according to the pixel ratio of that particular window. So the pixel ratio of my monitor and pixel ratio of your monitor is not the same. So to make it dynamic, what you have to do, we need to get the pixel ratio of that particular monitor of that particular window. So for that, let's say window dot device pixel ratio. So this will give me the device pixel ratio of that particular monitor. So to set the pixel ratio, we're going to use ternary operator. So here we are checking that if the window dot device pixel ratio is available, then use the window dot device pixel ratio. Otherwise, use the pixel ratio as 1. So if you don't understand the ternary operator, let me make you clear quickly. So if this statement returns true, then this statement will run, and if this statement returns false, this statement will run. So it's kind of like if else statement, but it's not if else, it's called ternary operator. So now what you have to do, let's say renderer dot auto clear equal false, and then renderer dot set clear color is going to be black color. So this is an hexadecimal value. If you want to set hexadecimal value in 3GS, you have to add this 0x before the hexadecimal value. So this is the hexadecimal value for black, and this is representing hexadecimal. Okay, so now we have to render our scene, and to do so, let's say renderer dot render, and we want to render our scene and our camera. Camera. Great. Okay, so we're done with our setup. Now we can import our 3D model, and to do so, first of all, we have to import the GLTF loader so that we can load our 3D model inside of our website. So first of all, let's import this. Let's say import GLTF loader from .jsm slash loader slash gltf loader.js. Okay, great. Okay, now let's console log it to see if we imported it correctly or not. Okay, console log and hit save, and now let's check, and if you see that we got an error. The reason we're getting that error is because we didn't map our imports. Okay, so to map the imports, what you have to do, let's go to HTML file, and in HTML file, inside of head tag, let's create a script tag, and let's give the type of the script tag is import map, and inside of this script tag we need an object, and the key for the object is going to be first key imports, and the value for this imports key is going to be another object, and here the value is going to be the path of our GLTF loader, and the path is going to be 3/examples/ loaders/ GLTF loader, and make sure you use the double quotes everywhere, is because if you use single quotes, it's gonna return you an error, so don't use single quotes. And then what you have to do, then give the path which I have given in here, just copy it, the path, and if I paste here. Okay, so now if I hit save and refresh, the error is still there. Because the error is still there is because we just map our GLTF loader. So if you want to just map your GLTF loader, you also have to map your main file of your 3GS. So to do that, let's say 3.module.js. Okay, so now if I hit save and if I check out, see our GLTF model is here, and we have some additional errors. Don't worry about this at this moment. We'll solve it out later. So our main problem is solved. Our GLTF loader is here. Okay, so in here in client.js, let's create a variable called house, and let's go down, and in here let's just create an instance of our GLTF loader. So now to load our 3D model, what we have to do, let's say loader.load, and now we have to give the path of our model. So our model is inside of model/scene.gltf. So this is the path of our model, and then you need to give a callback function, and this callback function, how are you gonna do in callback function? First of all, we are gonna store the model inside of our house variable so that later on we can animate it freely. So let's say house equal to gltf.scene.children, and let's give the index of 0. So basically our 3D model is inside of this children array and the index number is 0. So that's what we're saying. We're just taking the model and storing inside of our house variable. And then let's add our model inside of our scene. Let's say scene.add gltf.scene. Okay, so in that way our model will be added to scene. And okay, so now if I hit save and refresh, we can see our model, right? At this moment we can see our model, and we should see an error. Yeah, we are getting an error. So it says that failed to load the buffer scene.bin. So here we have the scene.bin file. So basically our GLTF loader was unable to load this file. So usually the scene.bin file is linked with our scene.gltf file, but in my case for this model maybe it's creating some problem. So if you're having the same problem, if your GLTF model doesn't show up, what you can do, you just can go to Google and search for GLTF to GLB converter, and then you can go to any website from here. And once you're in a website, just select your GLTF file, your bin file, and your texture file, and then drag and drop these files in here, and then hit convert now. But I have already converted this into GLB format, as you can see, scene.glb. So instead of using scene.gltf, we're gonna use scene.glb. So let's just say scene.glb. And now if I hit save and go to our browser, okay, so our error is gone, but still we can see the model. Okay, so the reason that we can see our model is because we need a function which will run in every frame and it will render every frame. Let's create a function. So there's a const animate. Okay, so I'm naming the function as animate is because we're also going to animate our model inside of this function. So let's say request frame animate. So what this function is doing, this function is simply calling this function again and again. Okay, so it's kind of recursive function. Then we have to render. So before we render, let's just create another function for rendering, const render, and just copy paste this line. Let's cut it and paste it here, and call our render method in our animate function. Okay. So now if I refresh, we still can see it. It's quite frustrating, right? So why we can see this is because we don't have any light source. First of all, let's create an ambient light. Let's const ambient light is equal to new, then 3 dot ambient light, and let's say the color is for time being is white. Okay, and the intensity of this color is going to be 2. And now let's add this ambient light to scene. So scene.add ambient light, and now if I save and refresh, we can see it. We should see it by now. Let me see the reason. Okay, we didn't call our animate function in our init function. So inside of our init function, let's call our animate function. And now finally we should see it. Yes, there you go. Our model is inside our browser where we can see it, but it's quite big. Let's just resize this. So inside this callback function, let's say house.scale scale.set is going to be 0.4, 0.4 and 0.4. So basically we're downing the scale, we are making it smaller. And then let's say house.position.set 0, minus 1.3 and 0. Great. Let's say hit save and refresh. It's perfect size, and I think we need to rotate it quite a bit. So let's say house.rotation.x is equal to math.pi slash or divided by -3, and then it should rotate our model according to our x-axis, and yeah, it rotated. Okay, so now what we have to do is that we can interact with our model. First of all, we need the orbit control. Okay, we need the orbit control if you want to move our model. So let's say import orbit controls from /jsm/controls/orbit controls.js. Okay, but similarly it have the same problem. If we try to work with our orbit control, it will give us error, and to solve that we have to map our orbit control. So let's go to our index.html file, and let's say 3/example/control/orbit controls, and the value is going to be jsm/controls/orbit Okay, so now if I console log our orbit control to see if we imported it correctly or not, console log orbit control, and if I refresh, okay, we are getting an error. Let me see.
2,000 years later.
Okay, after a long time of debugging, I saw this error. I just misspelled the orbit control. It's a silly mistake. Okay, so now I refresh. Yeah, now it's everything is fine. Our orbit control is there, and our model is also there. Great. Okay, so now let's add our orbit control. Okay, so let's say controls equal new orbit controls, and we want to control the camera. and then we want to control the renderer.dom element. Okay, great. So now again misspell. So now if I refresh and okay, I didn't define it, sorry. Const controls equal this. Okay, great, there we go. So now we can control our GLTF model and we can move it around, we can rotate it, can zoom in, zoom out, and all this stuff. Okay, great. Okay, so now what we need to do is that if you see, if I close our window, it stays the same. Now if I refresh, then it becomes full screen. So that's mean our website is not responsive. So let's just make it responsive. And to make it responsive, what we have to do, we have to create another function down here. And the function is, let's say, const window resize is the arrow function. Okay, so now what we have to do, we have to change the camera aspect according to our new camera aspect. So to do this, let's say camera dot aspect is equal to window dot inner width divided by window dot inner height. Okay, so then what you have to say, we have to update the camera. So for that, camera dot update projection matrix. Okay, and then we have to set the new size for our renderer. So let's say renderer dot set size is going to be window dot inner width, first of all inner width, and then window dot inner height. Okay, and then call our render function here. Okay, great. And now what we have to do, we have to call this window dot resize function whenever our window is resizing. And so do that, there's a window dot add event listener, and we're gonna listen for resize. So if your window is resizing, then we want to say window dot resize and then false. Okay, so now if we refresh, our window should be resized according to the new size. And let's go to our size. Yeah, so as you can see, now our window is responsive. And well, at this moment, don't worry about this vertical scroll, we'll fix it later. Okay, so everything is working right now, but one thing is missing is the light sources, the lights, right? Okay, so let's change the color of the ambient light a little bit. Let's give it kind of grayish, 4040. Okay, great. Now what we have to do, we have to set some additional light sources. So first of all, we want to add the spotlight. Okay, so before we use the spotlight, let me explain the ambient light a little bit. So ambient light is basically a light source which is light up your model from every direction equally. And now let's work with the spotlight. So let's say const spotlight 1, because we're going to use multiple spotlight. So let's say spotlight 1 and new 3 dot spotlight. Make sure the S and L is capital. And the color for this light is going to be 0x1D to 7 and F0. And the intensity is going to be 5. So now let's add this to our scene. Scene.add spotlight 1. So if I see now, we can see nothing. Okay, again I misspelled the spotlight. Okay, so you can see our spotlight directly in here. It's a blue light. Okay, it's at the top, but we don't want it at the top, right? We don't want this light at the top. So let's change the position. So let's set the spotlight position. So not ambient light, the spotlight dot position dot set. The position is going to be 6, 11 and 6. Okay, now if I refresh, yeah, now our spotlight is in a correct spot. But the problem is we don't know that where our spotlight is. So if you want to know that where your spotlight is, you can say that, let's say const spotlight helper. So we can create an helper to see that where is our spotlight at this moment. So let's say new 3 dot spotlight helper and this spotlight helper is going to be for our spotlight 1. So let's pass it, and then you have to pass that how big this helper you want. Let's say 1, and the color of this is going to be, let's say, green color. Okay, and now you have to add this spotlight helper in our scene. So it's a scene.add spotlight helper 1. Now if I hit save and if I check out, okay, again you can see nothing. Spotlight helper is not a constructor. Okay, again I misspell it. I don't know why I'm misspelling it again and again. Oh my god, this is terrible. Okay, there you go. But we can see the color of our spotlight. It's black. I don't know you can see this black lines or not. So basically here is our spotlight standing, but I don't know, I'm not getting the color. I don't know why, but I guess you can get the idea if you can see these black lines. So this is where is our okay, let me change the color of our background so that we can see it clearly. So in here, inside of this renderer, let's say alpha to true. So our background will be transparent, so you can see our helper clearly. Okay, so there you go. So this is our spotlight helper. Is our spotlight light is here, and it's emitting the light from here. Okay, so now we can set our another light. So let's set the light another. We want to set another spotlight. So let's say spotlight 2 and new 3 dot spotlight, and the color for this spotlight is going to be kind of orange. So the color is F57D22. Okay, and the intensity is similarly 2. Okay, so now let's set the position for the spotlight 2. So spotlight 2 dot position dot set. The position is going to be -10, 0 and 12. Great. And now let's add to our scene dot add spotlight 2. Now if I check out and refresh, our second light is added. Similarly, let's add the helper too. Let's add the helper. So const spotlight helper 2 is going to be new 3 dot spotlight helper. And let's see, we want to set this helper for our spotlight 2. Okay, and then the size is going to be 2, and I don't know why color is not applying here, but okay, that's okay, we can work with it. And now we can add this to our scene dot add spotlight helper 2. Okay, so here is our second light. It's emitting from this side. This is our second light. Let me just comment out the first one so we can see it properly. Okay, so there you go. This is our second light. It is emitting from this direction. Okay. The problem is, if we want to change the position of our spotlight, what we have to do, we have to change them here manually, right, like this. If I refresh, yeah, it changes. Okay, the problem with this approach is, at this moment I know that where the light is going to be perfect, but in your case, if you're working with a new project, you don't know that where your light should be or where your light is going to be look good. So to solve that problem, what we have to do, we have to add some GUI. I hope you have saw them before. So if you see our already created one, we have this kind of GUI which will help us to change our light position, right? Like this, we can change our light position directly from here, so that we don't have to go back again and again. So we can add this GUI so that we can change our light position directly from here, and we can see that which position is perfect for us. And so to do this, what we have to do, let's go back to our file. We need to add a GUI which is called dart.gui. So let's say import GUI from .dat.gui/libs/module.js. Great. And similarly, we have to just map it. So to map it, let's say 3.examples/JSM/libs/dat.gui/module. Okay, we don't need the JS in here. And JSM/libs/dat.gui.module.js. So now let's come down in here. Okay, so in here there's a const GUI equal new GUI, and then what we have to do, we have to say let's create a folder, as we're gonna, let me just show you. So the name blue light and orange light, backlight, and all of this is basically a folder, and I can fold it and unfold it. So as we are going to have multiple lights, so it will be better to add themselves in their separate folder. So let's say const blue light equal GUI dot add folder, and the name of the folder I want to be blue light, Okay, so now we have to add our XYZ coordinates inside of this folder. And to do this, let's say blue light, this folder name, this variable. Okay, blue light dot add. So what we want to add, we want to add the spotlight's position. So let's say spotlight 1 dot position. And which position we want to change? We want to change the X position, and then we have to set a minimum value, that which will be the minimum value of X coordinate, and this is going to be -30. And then we have to set a maximum value, that which will be the maximum value of our X coordinate, which is 1. And then we have to say another variable, another argument, which is the step. So that's means whenever we're increasing or decreasing, by how many value you want to increase or decrease. We want to increase or decrease by 1. Okay, so the step is going to be 1. Okay, great. So now if I save and if I go to the original one, so you can see our blue light, and if I change it, you can see the blue light helper is changing its position, and as well as it's changing the light. Can you see it? Let me make it black so that you can see it properly. Let me just comment out this alpha true. Refresh. Okay, so now we can move the light according to you, and you can set the position that where you want the position. So let's just duplicate it 2 times and just set it to Y and this to Z. Perfect. So now I refresh, I can move this any direction, and you can just set it from here. Okay, so for example, you are playing with this and you conclude that we want this light source in here. So what you can do, you can just copy this value, or you can remember this 2, 5 and 1, and you can set this value as default. What is gone? Okay, you can set the value as default in here. The value was 2 and 5 and 1. So now this light is going to be in here by default, but we don't want it in here. Now let's do the same thing with our light spotlight 2. Let's say const orange light, and again similarly GUI.add folder, and we want to name this as orange light. Okay, and then let's say orange light dot add. We want to add this orange light with our spotlight 2. Okay, add to our spotlight 2 dot position, and the position is X, and the minimum value is, let's say, 40. Minimum is -40, maximum is 40, and step is 1. And similarly duplicate it and just change the coordinates Y and Z. Okay, so we need another light. Let's create another light. Const spotlight 3 is going to be new 3 dot spotlight, and this is also going to be a blue light. So let's just copy this and paste it here, and the intensity is 2, and scene dot add, we want to add our spotlight 3, and also we're gonna add the helper variable const spotlight helper 3 and new 3 dot spotlight helper, and this is going to be for spotlight 3. and this size is 0.5, and I don't know why I'm setting the color, it doesn't matter to be honest. And let's scene.add spotlight helper 3, sorry, this is going to be our backlight. So let's add a GUI for this as well, so that we can set the position as we wish. So let's backlight is equal to GUI.add folder, and then I want to name it as backlight, and backlight and backlight.add. I want to add this backlight with our spotlight 3. So let's copy it, and spotlight 3 dot position, and the position is going to be X, and the minimum value is going to be -40, maximum is 40, and the step is 1. And just duplicate this and change the axis Y and Z. So now if I refresh and if I want to change the position, let me just comment out those two so that I can see it properly. Okay, so now let's set the backlight. Okay, I guess this is fine for the X, and Y is okay around here. Let's say the Z axis is going to be -17. I guess that should be fine. Yeah, I guess that's not bad. It's emitting light at the back. Okay, great. So now let's copy this. Sorry, it was -10, 18, and -17 for our spotlight 3. Spotlight 3 dot position dot set -10, and then 18 and -17. Okay, great. Comment out the alpha true. Okay, great. So this is looking perfectly fine. So what we need to do is we didn't animate our house and we didn't add this FPS thing. So first of all, let's add this FPS, and for that we need to import our stat. Let's say import stats from, and this is inside jsm/libs/stats.module.js, and great, this is it. You don't need to map this thing. Okay, in here let's say const stats equal new stats. So we want to add this stat inside of our body. So let's say document dot body dot append child, which we want to append the stats dot DOM element. Okay, but to see the FPS we have to update this in every frame. So what we can do this, if you remember the animate function, right? This animate function is calling in every frame. So we just can say, what we can say stats dot update. So this will update in every frame, and now we should see the FPS count. Yeah, there we go. Our FPS count is showing up. Great. And the thing what we left to do is the animation. So to get started with the animation, let's come down here before the animate function, and let's type a variable is step equal to 0. So we're gonna keep track of our animation using this step variable. Okay, so if you have a close look at our animation, what it's basically doing is it's basically rotating itself around the y-axis and it's changing its position around the y-axis. Okay, so how we can do this? We need to find a way that we can change its position, our model's position, continuously around the y-axis, and we can rotate it around the y-axis. So how we can do that? First of all, let's just increase our step variable by 0.2. Let's do 0.02. Okay, so now we have to change the position of our house. So do that. Let's say house dot position dot y is equal to. So how we can change the position? We can say math.sign, and then we can pass the step variable. So basically what it's doing, it's taking the step variable, the value of step variable, and we are passing the step variable through the sign function. So basically sign function give you a value from negative to positive. So in my case, suppose the step is 0.02. So in this case, our sign function will give us from minus 0.02 to positive 0.02. So if I console log this, okay, so as you can see that our animation is working, our the house is moving, and if you look at the console, it's giving me a value constantly from negative to positive, and then we're taking these values and we are changing our position of house according to these values. Okay, so now we are getting the positive and negative value, but we just want a positive value. So to do this, what we can do, we can say math.abs. So it's basically the absolute value, so it's gonna create the negative value as positive value as well. So let's console log this as well. Okay, so now if I check, see now in the console we are only getting the positive values, and our house is appearing like it's bouncing whenever it's reaching the end point. So now if you want to increase the height of this jump, what you can do is just multiply this whole thing by 2. Okay, see our jump height is increased, and if you more jump height, you can increase this 2 to something like 5, 6, 10, whatever you wish to. But in here, beside jump animation, it's rotating around the y-axis, so you have to do that as well. So to do that, what we can do, we can say house dot rotation dot y, and to rotate our house we're gonna use the cos function. So let's say math.cos and step divided by 3. And now if I run this and let's say console log it as well, console log, it's rotating, but it's rotating really too much, right? Say let's just divide this whole thing by 4 so that we get a smaller value. Great, so it's working. But it's not that fast as this. I mean, it's the rotation speed is quite slow compared to the original one. Okay, to increase the value, let's just first of all let's just convert them to math.absolute and put all of them inside of this math.absolute value. And then what you have to do, you have to multiply this. Now I'm multiplying this whole thing with a sine function. Okay, so in this way we should get the perfect animation. If you didn't understand pretty well what I did here, let me try to illustrate it. So here we have a sine function. sorry for the handwriting, I'm using only mouse. So let's say in sine function we have a value called 5. So our value will start from 5 and then it will go down until -5. Okay, and then again it will come up until +5. Okay, and then again it will go down until -5, and it will just keep going like this. So in that way we can get a sine wave. Okay, so it's starting from a value which we have given inside this sine function, and then it's going down to that particular values negative. So if we are given 5 in here, so it's going to -5, and then again it's coming back to that number which is 5, and again 5. So it's creating a sine wave. So we're just using this functionality, and we are taking these numbers and we are changing the rotation and the position. Okay, so we're done with the animation. Now what we need to do is we just have to add this HTML elements. To do this, let's go back to our HTML file, and we're gonna use Flexbox, and we're gonna use Flexbox to do this. So let's say create a div, and let's give the class called flex container, and inside of this flex container let's create a div. Let's say let's give the class of main content. Okay, so inside of this main content, let's say h1, and let's say we build your dream, and as we want the dream with different color, let's say we wrap around span tag, and let's give the class of span tag. Okay, so now let's create a p tag, and inside of this p tag I'm just gonna paste, I'm not gonna waste your time, and then anchor tag, and href is going to be nothing, and here let's say let's build. So now as we are using flex container, what you have to do, let's just cut it from here, and let's go inside of this parent container, and in here let's create a div, and this class name is canvas element, and inside of this div let's just paste our canvas. Let's go to the CSS. So in here I have some variables of CSS and some font link, so I'm just gonna paste it here, and these are simply CSS variable, or you can say custom property, and these are basically colors which I'm gonna use later on. And you can just type this variable as it is, or you can use just hexadecimal value wherever you need to use color, but I prefer to use CSS variables. Okay, so then what you have to do, so I'm gonna scale down the font size. So to do this, let's say HTML, and font size is going to be 62.5%. So next what you have to do, let's say body, and I'm gonna set a font. So let's say font family is going to be this, which is a Google font, I have already included it, and then font weight is going to be 700, which is bold. Okay, so now let's color the h1 and p tag. So let's say color, and I'm gonna use our variable, and the variable, let's say complementary color. And also let's change the color of our dream, and to do this let's see our class name was dream as well. Okay, let's change the color. So color is equal to, sorry, and the color is going to be accent color. So if I refresh, yeah, the color is changed. So next we have to use the flex box, so that we can make them side by side. So to do this, we have created a class called flex container. So let's say flex container, and let's set the display to flex, and the flex direction is going to be row, and the height is going to be 100 VH or 100 viewport height, and then the background color is going to be, let's say I'm gonna use primary color, and if you look at the primary color is kind of black. Okay, so now what I can do, if I check out, if I refresh, so as you can see that our text and our model is side by side, but the problem is that this is quite a small place for our text. So now let's increase that, and to increase this we have to copy the main content class. Let's copy it, and let's say main content, and I want the width to 40%. Okay, it's not working. Oh sorry, I didn't set the width for our canvas element. So let's select a canvas element, and let's set the width to 60%. Okay, now it should work. Yeah, great. So now, and in the main content, let's select the display to flex, and the flex direction this time is going to be column, and justify content is center to make our text center vertically. Okay, and let's add a bit padding. Let's say 0 from top to bottom and 2 EM from left to right. Okay, so now let's style the H1 tag. So let's select this H1. So I want to increase the font size of our H1, let's say 3.9 rem, which is 39 pixel, and let's make it to uppercase. Text transform is uppercase, and then margin bottom 0.8 rem, means 8 pixel or EM I guess. So now let's install the P tag as well. So let's say main content P, and similarly I want to increase the font size, let's say 1.7 rem, and the font family is going to be this one. This is a Google font, and the font width is going to be 400, and let's say line height is going to be 2.5 rem, and margin bottom let's say 0.7 rem or EM. Okay, so now if I refresh, okay, great. So now we have to style the A tag. So let's say main content A. Okay, so I want to set the font size. So let's say font size is 1.8 rem, and text decoration I want to none, text decoration none, and I want a background color, and the background color is want to be white color, and then color, so and then color, let's say color is going to be black, so black color. And now if I save and refresh, okay, so now this is how it's looking. And now what we have to do, we have to set a display to flex, and let's say align self to start or flex start. Okay, and now if we check it, okay, so now it's at the start position. And now what we can do, we can say padding, let's say 0.5 rem to top to bottom, and 1 rem from left to right, And the font family, let's set up font family is this, the same one we have set for PTag. And then font width is going to be 500. So now if we check, okay, it seems like that padding isn't applied. Oh, sorry, there won't be any comma, I'm sorry. Okay, refresh. Okay, great. Okay, so our CSS part is complete. This thing is looking good. So the only problem we have now is this vertical scroll bar, which isn't looking good. And to solve this problem, what you have to do, let's go to our client.js again, and inside of this client.js, what you have to do, we have to take the width of this canvas element. So to take the width of this canvas element, what you have to do, and here I'm going to create a constant. This is a const canvas size is going to be document.querySelector, and the selector is canvas element. So now instead of setting window.innerWidth, what I'm gonna do, I'm gonna say canvas size dot offset width. And similarly, instead of window.innerHeight, what I'm gonna do, canvas size dot offset height. Okay, so similarly in this where we are setting the size of renderer, just remove it and say canvas size dot offset width, canvas size dot offset height. So now if we hit save and check, so this is how it's looking right now. But the problem will be if I just inspect this. See, the problem is again coming. The problem is coming again is because we didn't set this offset width and offset height in our window size function. So let's set it here as well. So canvas size dot offset width and offset height, canvas size dot offset height. Similarly in here as well. So canvas size dot offset width and canvas size dot offset height. Okay, great. So now everything should be fine. Even we resize the window, yeah, everything is fine, and our scroll bar is also gone now. But the problem is, if you look the previous one, the background color is seamlessly everywhere is the same background color. But in our case, the background color is different, is because all we have to do is, let's go to renderer and just uncomment this alpha true. So it will make this black background transparent. So it will be this color which we have set in CSS document. Okay, so great, our background is completely fine and our animation is also complete. So there you go guys, finally this is complete. And thank you so much guys, thanks for watching this video. And if you have any question or any confusion, please let me know in the comment section. I will try my best to answer them. So thank you so much, take care, bye bye, tata.